Before we get started in today's lesson, I want to take a look at these simple warm-up problems. We want to know what two fractions sum to 5 6. And there's lots of different answers we could do for this. It could just be something as simple as 1 6 plus 4 6, or maybe 2 6 plus 3 6, or something like that. Same thing for 11 fifteenths. Maybe we say 3 fifteenths plus 8 fifteenths. Now, clearly 3 fifteenths does reduce. But that's what we have, is we can split fractions into smaller parts. And that is sometimes helpful when we have something more complicated like x plus 7 over x squared minus x minus 6. This is really a technique that comes back in calculus because pulling this thing apart makes some other things in calculus easier. So that's what we're going to be working on today, is something called partial fractions. Let me get to the notes. They're coming here. So in calculus, it is sometimes helpful to write a rational expression as the sum of two or more simple irrational expressions. We call this partial fraction decomposition. So we want to take this fraction and split it into smaller parts. So the steps, we're going to be going over these steps, increasing complexity over the next couple days. If it's an improper fraction, we want to use long division. I don't think we see any of those today. We always want to factor our denominator completely. And then linear factors get written as a over whatever the factor is, and quadratic factors get written as bx plus c over whatever it is. I don't think we'll see any quadratic ones today. So let me just show you how this works. This is the same problem from that warm-up that I was talking about, is we want to split this into smaller fractions. So the first thing we're going to do is factor the denominator. So the numerator is x plus 7, and the denominator is x minus 3, x plus 2. And my goal is going to be to split this into two separate fractions. Now, notice I have two factors in the denominator, x minus 3 and x plus 2. So I'm trying to figure out what's going to go on top of those. So since these are both linear factors, this is degree 1, all we have to worry about is having a constant on top. So I'm going to put an a there and a b there, and those just signify that those are constants. So I need to find a and b. So this thing that I've just written in blue, I'm just going to rewrite it down here so I can work with it. So this is the equation that we're trying to solve for both a and b. So the first thing I want to do to this thing is I want to get rid of the fractions, because that's a big messiness right there. So I'm just going to multiply everything by the denominator, x minus 3, x plus 2. I'm going to do that on both sides of the equation to all three pieces. And that's just going to cancel out stuff, so I don't have to worry about fractions at the moment. Okay, let me rewrite what we have here. On the left-hand side, we have x plus 7. And then we have a, x plus 2, plus b, x minus 3. Okay, this is what we want to solve. This is a super important equation. I'm going to star it because it's a super important one we're going to keep coming back to. Now, what I want to do is I'm just going to pick some things for x, just to plug in. So we are going to choose something for x, and we want it to be something easy. Now, look right here. If I pick negative 2, do you see that that term's going to be 0? So that's what I want to do, is I want to plug in negative 2. Let me show you what happens when I do that. So I'm going to start over here. I'm plugging in negative 2 for all of these x's. Okay, so I get negative 2 plus 7 equals a, negative 2 plus 2 plus b, negative 2 minus 3. All right, and now negative 2 plus 7 is 5. Now, this term, that was 0, okay? So it's just going to go away, and then I get negative 5b. So I have just found that b is negative 1, okay? Which is great. So now I know what b is. Now, we're going to go back to the start equation, and I'm going to pick something else. something else that'll be easy to plug in. So this time I'm going to let x equal 3 because that's going to make this term go away. So if I let x equal 3, I'm going to go back here and I'm going to plug in 3 for all of these x's. So I get 3 plus 7 equals a, 3 plus 2 plus b, 3 minus 3. So we have 10 equals 5a, and then 3 minus 3, that's just 0. So that whole term goes away. And when we finish solving this, we find that a equals 2. So now I have found what a and b are, so I can go back to my very beginning right up here. Remember, I was trying to find what a and b were. We just decided that a was 2 and b was -1. And that's my answer, okay? I took this original thing and I split it into two fractions that were slightly smaller and slightly more simple. And if you take this thing, that our answer here, if you get common denominators and put it all back together, you'll get back to that original equation, okay? So for college algebra, I mean, this is a calculus tool, okay? So the reason that we do this is to make things simpler once we get into calculus. So right now we're just kind of working with the algebra. We'll check out another problem in the next video.